Hi everyone, I am Bindeshwar from Post Network Academy, and in the last videos I have explained about measures of central tendency, in which I calculated mean, median, mode, geometric mean and harmonic mean for ungroup data and for a group data as well. Now in group data there are two types of data: discrete frequency distributed data and continuous frequency distributed data. Now if you see that continuous frequency distributed data, so data is in the form of range. So I'm just taking an example: class interval and its corresponding frequency. So 3 to 5, frequency is 2. 6 to 8, frequency is 3. 9 to 11, frequency is 3. 12 to 14, frequency is 2. And another class interval I am writing, that means I am taking another group data which has continuous frequency distribution. So class interval and frequency distribution. So 2 to 4, its frequency is 2. 4 to 6, its frequency is 3. 6 to 8, its frequency is 3. 8 to 10, its frequency is 2. Now you can see that both data, and in any class interval, the left side value is called lower limit and the right side value is called upper limit. Now you can see that it is starting from 3 and the last point is 5. The next class is beginning from 6, then 8, thereafter 9, and it is beginning from 12. 5 is not included in the next class, it is included in the same class. 5 is in the same class. On the other hand, in this data distribution, 4 is the upper limit and it is not included in this class, it is in the next class. So this type of classes are called inclusive classes. And here exclusive, because upper limit is excluded. Now the problem with inclusive class is that if you write 5.5, 8.5 and 11.5, so see that 5.5 is not here, also not here. The same way 8.5 is not here as well as not here. The same way 11.5 is not here and also not here. So these data are not, you can say that, in this class interval, in any class interval. So that would not be the best representation of data or a good way to represent data. So this problem occurs. So you can convert this inclusive classes to exclusive classes. So very simple. You will use correction factor and in correction factor you will take upper limit of the class here. I'm taking here. Okay. You can say that upper limit of the class. So you will write here 5 and lower limit of the next class. You will subtract from lower limit of the next class here. So I'm just marking it. That means here. And you will divide it by 2. So 6 minus 5 upon 2, and definitely that would be 0.5. And what will you do? You will just add this correction factor in upper limit and you will subtract it from lower limit. So just I'm writing it. So class interval and frequency would be the same. So 3 to 5.5, thereafter 6.5, not 6, 5.5. So just I am erasing here. 5.5, 5.5 to here 8.5. And here remember that also. Here also there would be 2.5 because you have to subtract. So I am correcting it. 2.5 to 5.5. 5.5 to 8.5. Thereafter 8.5 to 11.5 and 11.5 to 14.5, and frequency will be the same. There will not be any change in the frequency. So this data has been converted in exclusive classes. Classes of this data are converted into exclusive classes, in which you can see that upper limit of the first class is lower limit of the second class, and this all data are included. So this was about inclusive and exclusive classes. Hope you have understood. Thanks for watching the video.